Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about the instructions in 8051. Already we have discussed the architecture and its internal ports, special function registers and available registers, everything have discussed. Now we will discuss about the instructions. Instruction is one of the important one to develop the coding. The assembler coding we have to develop for the basic operations and also for interfacing the peripherals with the microcontroller. So, we have to know to develop any kind of specific applications. So, in today's session we will discuss about what are the instructions are available and how the instructions are executed for a simple applications or a simple explanations will be followed with that. So, before that we will discuss what is instruction. Instruction is a predefined binary pattern which is used to specify or perform the specified task. Okay. It is because from the binary pattern only we have developed the assembly level language. So, within that which consists of the mnemonics will define to perform the specific functions. Operand is a number which will to define either the data or address. Okay. So, the mnemonics which consists of the opcode and operand. So, instruction is a binary pattern only, which based on that after executing the opcode will be fetched and executed. Fetched means what will happen, the corresponding meaning what you have given in the mnemonics, like you are giving add means, then before that it will check whether the data are available in the temporary register, then it will after getting the control information it will start to perform the addition. So, that kind of fetching and execution will be performed by the opcode. So, which the corresponding mnemonics opcodes are available in the lookup table, it will refer and do the work, that is why it call it as a fetching and execution. These operations will be classified based on its length or based on its operations, right, based on its execution time also. So, based on the length how we are defining means either single byte instruction, 2 byte instruction or 3 byte instruction. In case of single byte instruction means which consists only the opcode. Opcode is operational code. Okay. So, within that only the mnemonics alphabets are available. Another one is 2 byte instruction. In case of 2 byte instruction, opcode plus one operand. What it represents? The operand is a data or address or 8-bit number along with one opcode, that is the 2 byte instruction. In 3 byte instruction, opcode plus 2 operands. The 2 operands are the 16-bit data, whether to how to initialize any 16-bit data or 16-bit address means we are using the 3 byte instructions, especially the jump instructions are mostly included in the 3 byte instructions. In 8051 we have one 16-bit register which is a DPTR, most frequently used for the programming. So, the DPTR instructions which is used with the 3 byte instructions. Okay. So, now we will discuss what are the types of instructions, how the binary patterns are arranged. Okay. So, based on its operations we are classified as data transfer instructions, arithmetic instructions, logical instructions and branching instructions. Okay. So, based on the operations we will discuss one by one with a simple example. Okay. The first one is data transfer instruction. Data transfer instruction means automatically it shows we are planning to transfer the data, right. So, in the previous processes we are having the different mnemonics for representing the data transfers, LXI instructions or STA instructions. Okay. For storing we have to use it a different mnemonics, for loading the data, right, everything having for 8-bit data, for 16-bit data the loading will be different, but here we have a single mnemonic which is MOV. Okay. So, usually the data transfer is performed between the source and destination. The common format is move d comma s. Here the s is the source, d is the destination. Okay. So, the data always transfer from source to the destination. So, while we using this instruction you are expecting the source and destination both should be a same size of the registers or data. Okay. Or memory, what it represents both should be same size means if it should be 8-bit or 16-bit, then only it will accommodate the data. Now, we have discussed the source and destination both are registers, right. What are the available registers in 8051 to perform this kind of basic operations? So, we have the accumulator, B register, then R0, R1, R2 up to R7. So, these are the registers. So, among these registers you can use it for anything. Okay. These all are 8-bit registers. What we are discussing, the data always moving from source to destination. Suppose I am taking the example for this, move R0, R1, right. Here R1 is a 8-bit data which is used in the place of source, then R0 is the destination register, right. After executing this instruction, the data will be transferred from R1 to R0. Okay. Now, R0 value is equal to R1, R1 already having some values, right. Suppose you are considered as a 5 means now the 5 is loaded in R0 and R1. Okay. So, after executing, the same value will be maintained in the source, only the destination content is changed. Okay. So, this is the transfer between the two registers. Based on this also we can give the addressing modes. The addressing modes, what it specifying means how the operands are specified in the instruction. So, here the source and destination both are registers. So, it also you can call it as a register addressing mode. Register addressing mode. Okay. So, the same format now we have used to transfer between the registers. Between the register you can use move A comma R1 also. So, what it represents, the data from the register, now the R1 value is moved to the accumulator. The content of R1 does not change, now only the accumulator content is changed to the new value which is R1. Okay. So, these two R is name it as a register addressing mode. Okay. So, for that how we are using means the same mnemonic move, any one of the register you can use it, or simply you can give the destination comma the data. The source is replaced with the data which is the immediate data. The immediate data is represented with the symbol. The immediate data is represented with a hash symbol. Okay. So, this is a destination register, any one of these registers you can use it for the destination. For example, you can take it as move A comma hash symbol of 36. So, what it means that 36 H we are using because the H represents the given number is a hexadecimal. So, after executing now you get accumulated value is equal to 36. Okay. So, this is the way we are initializing our data into any one of the specified register. The same thing you can use it for any one of the register. Suppose you are want to load the data in R1 means R1 hash symbol with 90 H. Okay. So, now the 90 H is loaded into the given register R1. Either this way you can use it, or here in 8051 each register having some specific address. Some specific address already we have discussed in the RAM allocation. RAM allocation, the R0 is initialized with 00, then 01, 02 like that, it is a 07. So, these all are for bank 0, right. In case of bank 1, here also it start with R0, R1 up to R7, but the addresses are varied from 08, 09 up to 0F. This is for bank 1. Okay. So, this way already we have discussed. From that what I want to replace here as either you can use the term as R1 or it will be replaced with its corresponding address. Suppose if you are giving move 01 comma 90 H. Okay. So, either you can use these two formats, move R1 comma 90 H or move 01 comma 90 H or R1 comma 90 H. After executing these two instructions, the output is common, R1 is loaded with the 90 H. So, the registers can be used with the by the name or by the address also you can use it. In case of bank 0, we have used the address as 01. Suppose if I am using move 09 comma hash symbol of 90H means what it will understand, this R1. Okay. In bank 1, the R1 which address is 09. So, the given 90 data will be loaded in the address. Okay. So, this is one of the representation. Either you can use the symbol hash symbol to load the data into the any one of the register, or you can load into its corresponding address also, but the execution will be same for both. So, now we have discussed only a data transfer between the register, how to initialize the data, right. So, this kind of data initialization, right, here we are giving the immediate data, right. So, while initializing the data, it will be call it as a immediate addressing mode. Here both are source and register, both are register, that is why we call it as a register addressing mode, right. Here the source is a immediate data, destination only the register, we are initializing the data into the specified register. So, this kind of addressing modes where the source is a operand, then it is called it as a immediate addressing mode, or you can easily understand wherever have the symbol of hash symbol, you can call it as a immediate addressing mode. So, one more instruction which is used for initializing the 16-bit data is, for 16-bit data we are using move dptr hash symbol of, this is a 16-bit register. So, you have to give the 16-bit data. So, 134H if I am giving. Okay. Now, we have initialized the 16-bit data in the 16-bit register. So, which is the DPTR, the DPTR actually internally divided as a 2 8-bit DPL and DPH. So, what it represents, this is a lower byte register, this is a higher byte register. So, the given 16-bit data which is 1, 2, 3, 4 is also having the lower byte data and higher byte data. This 34 is a lower byte, 12 is a higher byte. So, the corresponding data will be loaded in the corresponding register, which is 34 is loaded in the lower register, the higher byte 12 is loaded in the higher register. Okay. So, this way only the data is initialized. Based on your requirement, you can access either DPH1 alone also you can access it. Okay. So, only one 16-bit register we have, which is a DPTR. After giving the value, it will be loaded in the lower and higher registers. Okay. These are the simple 8-bit initializations either in the accumulator or B registers or any one of the register in the register bank. So, generally how we are defining the move instructions, this is one of the important instruction in the data transfer, which will play a vital role for transferring the data, for initializing the data, for storing the data, for accessing the data from memory, for everything, right. So, we have to give what is source and destinations, both should be a 8-bit register because here it is a 8-bit microcontroller. So, we are focusing both should be 8-bit, then the source will be an data, but the destination should not be a data because the destination should be used to hold the data. So, it should be a any one of the register or it might be a memory, okay. But the source should be the data to initialize the value. Then you can access the data from memory also. So, the source and destination both can be a address. So, within that you can access either the address will be directly specified or you can specify it in the indirect way. Okay. So, what are the 8-bit registers in 8051 means R0, R1 up to R7. So, 8 8-bit registers are available in 4 different banks, bank 0, bank 1, bank 2, bank 3, each having the R0 to R7 of 8 registers. So, totally 32 8-bit registers are available and the special functions of A and B also available, both are 8-bit registers. Okay. B is a general purpose, you can use it for any kind of applications, and especially it will be used for the multiplication and division. This A register also call it as a accumulator register. Okay. A is a accumulator register, it also call it as a special function register. Why we are call it as a special function register means this accumulator not only used for initializing the data, it also used for the arithmetic and logical operations. So, for arithmetic and logical operations, one of the data should be loaded in the accumulator, right. Another data will be in any one of the registers or any one of the immediate data. So, now the data is added with the accumulator and the result is stored in the accumulator. Okay, that is why it called it as a special function register. The same thing also performed in the logical operations. So, for performing logical and arithmetic operations, the accumulator is used to perform the operation and also to store the result. And the another one is, whenever you want to access the data from the memory, it should be via the accumulator. So, via the accumulator only you can access the data from memory, and when the controller interfaced with the peripheral devices, that time also it accessed via the accumulator. Okay. So, for external communication, for memory access and for arithmetic logical operations. So, for all this accumulator is additionally used compared with the other registers. That is why among these 8-bit registers, accumulator is called it as a special register. So, now we will continue with the discussion of the move instruction. So, move instruction, the format is move destination comma source, right. So, if both source and destinations are registered, then it is called it as a register addressing mode. If source is the data, right, destination is a register, means it is called it as a immediate addressing mode. Now, we will discuss the same instruction format used for the memory access. Memory access means RAM address we are mostly using, the RAM which is a 128 byte available in 8051, which is a 8-bit. Okay. So, the address is mostly used from 0 to 7F. So, within this address you can use it for accessing the data. So, from the RAM, if you want to get any one of the data to any one of the register, means suppose you want to read the data, means what kind of format we are using, move accumulator comma the number, suppose you can use it as a 50H, 50H, okay, without any symbol in front of the number we are using. So, by this what it represents, the 50 is the address. Okay. So, while executing, what are the data, suppose you consider this is a memory, RAM memory. Okay. The starting address is 00 to 7F. Now, I am taking the location 50, 50 having the value of suppose 29H. Okay. So, this is a memory, each memory is identified by its address, each address locating a byte, it is stored in that. Now, you are giving 50H. So, what it represents, from the 50H the data will move to the accumulator. So, after executing this instruction, now the accumulator value is, what is that? The content of the 50, what is that? That is the 29H. Either you can initialize with move a comma hash symbol of 29H. If you have known the value, then you can use it direct initialization of this. Suppose you are initialized in the stored in the memory, means via this instruction only you can access it. Okay. Via the 50 you are accessing. So, without any symbol, only 50 or only the operand or only the number is available, means that is the address. So, the address of the RAM. So, from this the content you are reading and move to the accumulator. So, not only to the accumulator, you can use it for any one of the general registers like move R0 comma 50H. So, after executing this instruction, now R0 value is equal to 29H. Okay. So, if you want to use an array of n numbers or a bulk of numbers you have, you can initialize the memory, which will be easy to access. If you have a single data, you can use the immediate addressing mode to access it. Okay. So, here we are reading the data. Suppose I have the data, I want to store into the memory. So, in that case, how you are using the instruction means, just I replace the destination as the address. So, move 50 comma accumulator, right. So, what it represents, the data from accumulator is moved to the given address 50. always the data is moved from source to destination. Here source is the accumulator, destination is the 50, right. So, from the accumulator the data is moved to the 50 H. So, here what we are getting, the value, accumulator value is moved to the address of 50. So, after executing this, or suppose here if you are giving 51, okay. So, here the content 51, the accumulator value is moved, okay. Suppose you are assumed as accumulator value is 99 H, then here 99 H will be loaded, okay. So, this is a way. Here what we have done, we are writing the data into the memory, right. Here we are reading the data from the memory, okay. So, based on that you can name it as this instruction is a read operation, this instruction is a write operation. So, the write operation not only from the accumulator, you can use any kind of registers from R0 to R7, move any address within the 7F you can give it. Suppose I am giving the number 35 comma R1. So, what it represents, the given value in the R1 will be stored in the location of 35. Okay. So, now the value is unknown value, right, what the value in R1 will be loaded in the specified address. So, based on this, here we are using only the address to access the data. So, this instruction, okay, this instructions all are call it as a direct addressing mode. Direct addressing mode means in the given instruction the address is directly specified, right, that is why it call it as a direct addressing mode. So, based on the instruction usage you can understand what kind of instructions were used, right. Here both source and destinations are registered. Here what address is used to access the data, that is why it call it as a direct addressing. Here you are initializing the data, that is why it call it as a immediate addressing mode. Okay. So, the same instructions also used to initialize the known data can be directly loaded into the memory by using the instruction, same instructions you can use it, move 35 comma hash symbol of 45. So, what it represents, the data, given data, immediate data is moved to the address 35. Okay. So, suppose this is a address location 35 means its corresponding byte is 45. Okay. So, the data is stored. This is also possible in the 8051 microcontroller. The another one is, suppose I accessed from this memory, okay, but I am not interested to use the value of 50, means what, how we are writing is, initially I used the instruction move R1 with a hash symbol of 50. Okay. So, what it represents, R1 equal to 50. Now, I am using move accumulator comma at R0. So, what it represents, this is the indirect addressing, right. This symbol is used to represent the indirect addressing, because the address is not directly specified in this addressing mode. Okay. So, what is the meaning of this means R1, right, because here R1 only we are initialized. So, the value which is stored in the memory 50, the content of 50 will be moved to the accumulator. The content of 50 is moved to the accumulator, that is you can say the value, suppose 29 means after executing the accumulator value was 29 H. Okay. So, this way you can use it. For the indirect access we cannot use all the registers, only R0 and R1 is used. Among the R0 to R7 only 2 registers, 8-bit register and DPTR also you can use it. So, these 3 are preceded with the symbol at, which indicates it is a indirect addressing mode. Okay. Either this is we are reading from the memory. So, this is read instruction. For write instruction you can use move at R0 comma accumulator. So, what it represents, the data is moved always from source to destination. So, the accumulator content is now stored in the register which represents the memory, that is why it call it as a indirect addressing mode. Okay. So, this way we have read and write from the memory also. The another instruction is external data access. for external data access means, because we have discussed the three basic formats, right. So, till this we have completed this move instruction. Now, we are moving to move x. Move x is the data external access. External access means internally we have the RAM of 128. Suppose other than that you can extend up to 64 kilobytes of the memory. So, when you are accessing from this external memory of 64 kilobytes, then we are using this instruction, which is move x. Okay. Move x is move external. Then via the accumulator only we are performing. So, accumulator at indirect register we are using for this. So, indirect register, the indirect registers are R0, R1 and DPTR. So, for read operations from the memory we are accessing. So, the source is a register at R0, move to the accumulator, or at DPTR you can use it to accumulator. For write operations from the accumulator to R1 or accumulator to the DPTR. So, this is the external access, okay, for read and write operation. The same thing, one more instruction in the move, which is move code, right, which is to perform the external code memory access. External code memory access means which is a ROM. So, internally we have 4 kilobytes, other than that which is 64 kilobytes you can extend it. When you are want to access via that, we are using the move C, move code, accumulator comma at accumulator plus DPTR or via the program counter. Here we are using only the 16-bit register, DPTR and program counter. This is a relative address, the base address plus relative address, that both are added, then its corresponding content only move to the accumulator. So, these two are read operation, these two are the write operation. So, this is a memory, okay. The starting address is 4500, then here I am giving the location of 100 or 10 if you are taking, then this is called it as accumulator relative address, then this is the program counter address or DPTR address. So, what it will do, the 4500 plus 10 is added, then you get it as a 4510. This content only moved to the accumulator. So, this address is loaded in the DPTR, then we are using it with the at symbol. So, these are the basic 3 instructions used in the move instruction. Move format is which is used in the data transfer, move destination comma source. Okay. The source and destination both should be a register, it should be a 8-bit, okay. Either it will be a immediate data or memory access or indirect access, everything will be possible by using the single mnemonics. That is the advantage in 8051 compared with the other processes, it is easy to write it. Okay. Then when you are accessing with the external memory, you have to use with MoveX. When you are accessing with the code memory, especially the program memory which is a ROM, you have to use the MoveC. Only the 3 different formats we have discussed on this session. Hope you get understanding of this. Thank you.